Hi, and a very good day to my panels, Madam Ruzlawati and Dr. Sahasati. Today, I would like to present my project, but before that, I would like to thank my supervisor, Injit Zube, and my co-supervisor, Injit Kama. So, let's look at our presentation. All right. Okay, the title of my project is Development of GUI for the Prediction of Air Conditioner Energy Consumption. The real meaning for GUI is Graphical User Interface. So my respected panels might have think why I choose this project. This because this air conditioner is almost an essential product to be used in everywhere. So this is due to the outside temperature, warm outside temperature because of our global warming. So if we look at it, almost everyone and everywhere this air conditioner have been used, but not everyone knows how to predict the energy consumption of this air conditioner. So that's why we took this as our project to provide them with the prediction tool to manage their electrical bills. So as for everyone, our FTK also suffers without knowing to knowing to predict the air conditioner energy consumption. So we like to help our FTK to overcome this problem. So for the for the objective, okay, to predict the energy consumption of an air conditioner at the FTK. So we have fixed an compressor. So we'll go there every day and take actual data from that to do our prediction. So the data we gather from the air conditioner system at FTK will be focusing on vibration and current. So that will be very helpful for our GUI production. So to develop the GUI that can be used for prediction of the air conditioner energy consumption, we might use some software such as Excel and MATLAB. Okay, so the research or methodology. If we look at the research methodology, I have did the research like from journal, article, YouTube, Google. So almost everywhere I am finding for this thing and learning about this prediction. So the things I used here is I've used a clamp meter, vibration meter for the measurement of current and vibration. The vibration meter is for the measurement of vibration and the clamp meter is for the current. So with that, I get the vibration results and the current result. I can gather all the data first in the Excel. So with that, I can do the GUI in our MATLAB. So let us discuss our results here. Okay, without wasting time, we might look at the Excel and MATLAB. Okay, for the result, we might take a look at my table here. Okay, if we look at this, okay, this is my day one data. Okay, I collected all these data starting from 11 a.m. to 4 p.m. So these data I get almost for one day I will get 21 data. Okay, I get these data for almost around 15 days. Yeah, I got this for 15 days because we were planning to take more data like 1 or 2 months like that, but then the situation was not good. Last year was COVID, and then we couldn't able to enter the lab and take the readings all. So we managed to get the 15 days data. So if even though it is 15 days data, but it is really good for our regression analysis. So if I've gathered all the data here. So I've got around 315 data. So I did a vibration regression analysis for current. So I did variable, a single variable for each graph. So the same goes to the energy consumption. I did graph for each and every variable that I got, which is x, y, and z. Okay, so but then I have separated the data I collected like dry season and wet season. So the prediction will be more precise if we predict with dry season and wet season. So I collected these dry season data for around 200. Yeah, I got 217 data here, and for the wet season is around 110 data. Okay. Okay, so I did a regression analysis for both different season separately. Okay, I've highlighted these regression analysis with the key important factors that we need to have a look. Okay, R square. This is one of the important factor, that is the variance of our variables. Okay, if the reading was 0.03, it means it is just 3% variance in our variables. So it is not that effective, but it still need to be taken into the consideration. Okay, after that we can take a look at our observation. We got 210 data for dry season. Okay, then regression. We see the regression at the significance. It is 0.08. Usually if it is a strong regression, we need to have 0.05 and below. So now we got 0.08, so it is not a strong regression. So the coefficients like this x, y, z, this is our y intercept, this is our x variable, y variable, and z variable. These are the key factors that we need to do equation. So after that we can see our p value here. The it is same like the significance. The p value has to be 0.05 and below to be a strong regression. So if we look at here, the value is very less, it is less than 0.05, so it is a strong regression. So same goes to the wet season. I've plotted the regression data graph and a linear line graph for that as well, something like this. So we might have a look at the MATLAB. Where's the MATLAB? Okay, so to bring out the MATLAB, you have to press guide. It might take some time to seen in the screen. Okay, okay. Okay. So if you want to look at the coding, did I did different coding for different buttons here. So for example, if we look at the solution button for the dry season, I have declared x, y, and z with the energy consumption equation. This is our equation. So with this equation, this interface will produce its prediction by itself. So it is very fast. We can see that in a while. So apart from that, I've also included a solution button here. Okay, we might have a look at the coding. So I've differentiated the dry season and wet season with putting a number 1 here. You can see the number 1. So the prediction will not be confused when it is dry or wet season, because we need to differentiate both. Okay, so the equation is here for the wet season. Okay, now let's try. Oh, before that, there's a clear button here. So why I put the clear button is to clear all the readings we entered in a fast way. So we no need to clear one by one. So these are the coding I did. So everything, if I press the clear button, the every data will be cleared by itself. So let's run and see. Okay, Okay, we'll just assume numbers. This is not the actual data, but we'll assume for the test run. Okay, I'll put 0.12, 0.13, and then the z variable is 0.14, just assumption. And if we calculate it, so we will get 0.57723. How we should how we should believe that this is the correct answer is that I've already calculated this in my phone, so I've get the same result. So what I can say is the GUI is really working good. So we can test here also. Two, one, three, 0.14. So we can see the answer also. So if I tap the clear button, you can see all the data has been erased. So this is for my result. The GUI is working really well. And then might go back to the okay. Overall, as a conclusion, I can say that this project was a success because the GUI is able to calculate the able to predict the energy consumption by its own, and it's a fast and efficient way to be used. I might say that this GUI will be helpful for one person to manage his fluctuating electrical bills by managing his usage of air conditioner. So for future recommendation, I would like to say that I would like to learn more about this uh, managing my bills, because the aim of this project was to create a GUI. So I didn't know much more about that, the electric managing the electrical bills. So I'd like to learn about that. So thank you for listening to my presentation, madam. Have a good day. Thank you.